In this video, we will see segmentation in memory management. A process is divided into segments. In paging, we say that process is divided into pages. Here, it is divided into segments. So, what is a segment here? The chunks that a program is divided into, which are not necessarily all of the same sizes, are called segments. Segmentation gives users view of the process, which paging does not give. There are two types of segmentation: virtual memory segmentation. Here, each process is divided into a number of segments, not all of which are resident at any one point in time. In simple segmentation, each process is divided into a number of segments, all of which are loaded into memory at runtime, though not necessarily contiguous. There is no simple relationship between logical addresses and physical addresses in segmentation. A table stores the information about all such segments and is called segment table. A segment table maps two-dimensional logical addresses into one-dimensional physical address. Each table entry has base address and limit register. Base address, it contains the starting physical address where the segment resides in memory, and limit specifies the length of the segment. The address generated by the CPU is divided into segment number and segment offset. Segment number is the number of bits required to represent the segment, and offset is number of bits required to represent the size of the segment. Here is the translation of two-dimensional logical address to one-dimensional physical address. So CPU generates logical addresses. Here this is segments address. Here this is segment number. Segment number, and it loaded with the segment table, which contains limit of the segment and base address of the segment. This limit is calculated on offset. This limit is compared with the offset of the logical address if the limit is less than the offset. If the limit is less than the offset, then it is added with the base address and gives the physical address. So this base address is the starting of the address location, and when it's added with the limit register, it will give the offset of the particular segment within that segment size. Here is the logical view of the segment. Here we have base addresses of each segment: 0, 1, 2, 3, and 4. So this is the base address, and this is the limit address here. So you can see this base address here, segment starts in the 500 address and its limit is 600. So 500 plus 600 is 1000. So any address generated between 500 to 600 is valid. If the address generated by the logical address is more than the limit register. For example, if the limit, limit says 605, which ultimately will lead to 1105, which is the not available segmentation space for memory. So this is how the segmentation logical address space is converted into physical address space here. Then the advantages of segmentation include: there is no internal fragmentation in segmentation. Segment table consumes less space in comparison to page table in paging. And disadvantages of segmentation here: as processes are loaded and removed from the memory, the free memory space is broken into little pieces, causing external fragmentation. So segmentation suffers from external fragmentation, and it is a solution for internal fragmentation. In the next video, we will see more about the operating systems.